right now, since that's the one, that video seems to be cursed for whatever reason, keeps coming out not great. So, but if you're working on other forms, it's still a good idea to go through all the different videos because the questions are so similar from test to test that you might learn one thing on one video that, you know, might make sense in the context of the other stuff. So just let me know if you have any other additional questions beyond what we're doing here. So I'm going to keep one of these open. So we're starting with a question about digital sound samples. And so it's the way the samples work, and I don't know if you guys understand, you kind of have to have some understanding or be able to understand how sounds are stored, but it's basically just a series of amplitudes or volume levels for the sound itself. So it says in the beginning, it is represented as an array of integer values. So we have this integer value samples, right? Or this array integer or integer array samples. So what I do, like when I'm working, and this is a good idea for you to do when you're on the actual test, is just whatever instance variables you think are going to be super relevant, just copy and paste them into your code. It's not going to hurt anything. If it distracts you later, you can always delete it. But it's a really good idea to keep track of it and make sure it's there. And part A is going to be this, where we're going to limit amplitude. And if you go through the reading here, essentially limiting amplitude kind of works like, I don't know if you've used like Spotify or iTunes, both have a feature where you can normalize the volume of all your songs. So like different songs are recorded at different volumes, right? And when you go to play them back, especially if you're playing them loud, sometimes from one song to the next, it can be annoyingly loud versus I can barely hear this. So a lot of times you check that box and it kind of evens everything out for you so you can listen to everything at the same volume. Same principle is going on here. It's just we want to ensure that our sample doesn't go above a certain recording volume, right? So we record all the different places where that sound has gone amplitude wise, and we're going to limit them to a certain number and make sure they don't go over and under. So that's our job here, is to write that method, limit amplitude. And basically it looks through the array and it's supposed to find any values that are greater than the limit and change them to limit. Now, the problem is we have to think about amplitude in terms of distance from zero. So an amplitude of zero is complete silence, right? If something's negative 4,500 and our limit is 4,000, right? It's still more than 4,000 distant from zero, right? The distance from zero is still over 4,000. So I have to change that. So I have to do something within the code to deal with negative numbers. Let's see. So we have a parameter that says the limit that we're going to change to, and we're also returning the number of values in the sound that we changed, right? So we're going to need an int to count, right? And that's probably going to start off as 0. So I'm going to skip to the solution. And there's a couple different ways to do this, but I feel like this is probably the easiest. So what we want to do is we're going to tackle this first, right? We're going to, oh, I copied the wrong one in there. Let's see. Let's try that again. What am I on there? Let's go to warmth. 3. There we go. Okay, so we're going to limit the amplitude. All right, so we're taking in this amplitude limit. Remember I said we're going to make this integer count 0. Make sure, let's go ahead and copy this so we remember it's there. All right, so we have this integer array. We're going to loop through it, and if our distance from 0 is greater than limit in any way, we want to replace that distance with that distance from 0 with the limit distance, right? The problem is we have to differentiate between positive and negative numbers, right? So we do if samples at I is greater than limit, we change it to the regular limit, and then we add 1 to the number of changes, right? Because we just made a change, we add 1 to the number of changes that we made to the array. Otherwise, if we can also check if samples at I is less than whatever the negative version of that limit is. So if my limit's 4,500, if samples at I is less than negative 4,500, we change it to negative 4,500. So in either one of this is just saying, let's find out if it's positive or negative, then assess the difference between, or the distance from 0, right? So in any case, if the distance from 0 of the amplitude, or the amount louder than complete silence, is greater than whatever the input limit value is, then we're going to change it to the limit value or lower it to the limit value and up the count of our number of changes by 1. Questions on that one? All right, I feel like part A of that one, once you understand the actual how the samples work, that one is pretty straightforward. So now we go to part B. What we're going to do with part B is find the silences. And this one's a little tricky because there's a few different ways to do it, but I feel like there is one easiest way. And hopefully I can do a pretty good job of explaining to you how that works. So we have this array, right? And we want to remove silences from only the beginning. So we just discussed what's complete silence is going to be, right? What's the amplitude of complete silence? 0, right? So if we just basically take like the first few zeros that we have in the sample and we'll get rid of them. So basically any algorithm that you write that does that works here, because I don't think you have to use anything that we've had before except for samples array, right? So we have samples array and we're going to trim the silence from the beginning. So here's the easiest way I think to do it. And there's a few different ways that I offered you, but I think this is the easiest way. So I'm going to get rid of the ors here. Let's see. So we have to first determine the number of silent samples. The thing we got to remember is this is a regular array. Can we change the size of the array? We cannot change the size of the array, correct? That's the way arrays work. We can't change the size. What we can do is create a new array that has all the same values, just minus the 0 amplitudes, right? So first we have to find out what size that is, or essentially the size of our original array samples without the zeros. First thing we need to do that is find the number of zeros. So we loop through samples, right? While samples is 0, we add 1 to n. Is anybody confused by that? Because when I was at your level, I was probably a little bit confused by the fact that this kind of says find all the zeros, right? But if you think about when it stops, let's go back to the example, right? It says while n is 0, right? So if I don't even start with a 0, if my first value is 14, am I going to have any beginning silence? There might be silences, right? There's a couple zeros here and there, but there isn't silence at the beginning. So there wouldn't be anything to trim. The second thing is, if I have an example like this, as soon as I run into one amplitude that's not 0, right? Game over. I already counted the number of silences, right? Or the number of beginning silences, because it's no longer a beginning silence once it's not all in a row anymore and you run into a number. So n++, as long as samples at n is equals 0, and I'm starting at the beginning, so that takes care of that. So at this point, n is equal to the number of zeros, or the number of beginning zeros that we have in samples. Now all we have to do is declare a new array that's equal to the same length as samples, just minus the number of zeros, right? Because we're going to remove those. So now it gets a tiny bit tricky here, but there's a couple of different ways to do it. The easiest one is this. You start at 0 and you loop through the new samples array, not the old samples array. And that means for sure that you're going to run the loop the exact number of times so we get all those good numbers out of there and put them into our new array. So we're going to make sure that our new samples gets the exact number of values that it wants. And then we just add n, right, to the index that we're putting into samples. So I'll give you an example. We're starting at 0 here, right? Which is that's the first position in new samples. But in our regular samples array, the actual values that we're going to start putting in starts at n, which is just past the last 0, the last beginning 0. Does that make sense to everybody? So once we've established that, all the beginning zeros are out of the way, and we can just add numbers. And by the time this gets to length, this one has got to length 2, and we've added all the numbers that are not beginning zeros by the end of that loop. Then what we can do, remember we said that we can't change the size of the array, but we can take this variable samples and we can make it refer to a different array that's a new size. So now samples, we basically changed what the array variable samples refers to, which is our new samples array that's smaller and has no zeros at the beginning. Questions on that one? Okay, so let's move on to part 2. And if you want to ask me any questions on these privately, please feel free to do so. I'll be around a lot the next couple of days. So this one's a little tricky. Like I said, I think I've said this a few times now. Again, every single one of these tests has the one question on it, or every single form that we put on the quiz. Every single one of them has a question that's kind of borderline unfair. This one's a little bit more, it calls back to like integrated math 1-ish sort of a subject. So not understanding the math in this case is kind of can get in your way. Without getting too deep into how the math itself works, we're going to I'm going to show you how this works. So an AP line is defined by that equation, right? Which is, that's point slope formula, right? So if we look it up, images. So it's point slope, but it's not in the correct form. It's the other two variables are on the other side. So we're trying to figure out. So if we did the slope is defined as the value a divided by b, right? Point represented by integers x and y, so those are basically coordinates, is on the line if you substitute those into the existing equation. X and y is on the line if so it gives you the mathy part, right? So if you didn't totally understand it, these two things are equal to 0. You're basically the essential part of it is finding out if you had this slope of the initial a and b, and you multiply that slope by our coordinates, and we still come out with 0. That means that the point that we're bringing in as a parameter is on that line, right? It's in that same slope, so it's on that line. But again, it gives you it's saying that it is on the line if this is true here, right? So we just have to find that out. So you're it's giving you like an example of input and output, and then it just wants you to write the AP line class. Okay, so we have to be careful about knowing exactly what AP line is supposed to contain. Okay, so says must include a constructor that has 3 integer parameters that represent A, B, and C. So we need private integers. We need to take in parameters, have the constructor set them up. Anybody confused by that part? Okay. Then we're going to get the slope, and we know the slope is A divided by B, right? So even this, if you didn't get the mathy part of this exactly right, and even if you don't on the quiz, as long as you remember that A divided by B is involved, probably okay. As long as it's implemented in the right way and we're returning it and everything looks good. Then we have to write, let's see. So we wrote get slope. So we're here. Then we're going to say if this. So let's see. Okay, so now we're writing the method is online, and if it's going to return false if the point is on the line, true if it's on the line, false otherwise, right? So how do we didn't it already tell us exactly how to tell if it's on the line, right? So literally, if we just call our integer variables the same thing that it did in this paragraph, right? All our parameters and everything. If we just name things properly, this becomes super easy because we can literally just write this out in code, and that's going to evaluate to true or false anyway, because that's a Boolean condition, right? You see those double equals, we're done, right? All we got to do is return that. You could say if, this.
What you could do is put the equation in parentheses.
Yeah, you could do that. You could do if return true, otherwise return false, right? But there's no reason to do that. We can just return that. It evaluates to true or false anyway. How about this one, guys? Are we confused at all? All right. For me, that one is like, okay, I got a little bit shaken up by the algebra that I can't remember, but in the end, they give you basically everything that you need to solve. Like they basically tell you how to solve the equation in the question. So I don't really think that one's that bad. Borderline unfair because of the mathy stuff, but not like the biggest deal ever. So now we're doing student objects and seating charts. So a little bit different. The last, either the third or the fourth question on either one of your forums is going to have something to do with either arrays or array lists of objects rather than any kind of primitive data values, right? So this is one of those. So the thing you just have to remember is that anytime you pull something out of an array with these, you're going to probably run some methods on the objects themselves and get different kinds of values. It's not going to be just one, oh, this is what, I'm going to get this number and return that. It's more, I'm going to get this object out of the array, run a method on it to return the particular value that I'm looking for. And that's pretty much how this one works. So we have to be really careful about keeping track of our objects, right? And knowing what they do and what they're capable of. So we have student class, which is pretty basic, right? It has get name, and it says this here, and in this case, I believe it's true. We're going to need to know, I think this one we need to know the number of absences. And then we have also a seating chart where most of the data values in that object are represented by a 2D array. So, which if you think about that for a second, 2D array is like a grid, right? So that's kind of a perfect thing for a seating chart if we're going to conceptualize it in our code. Let's see, seating chart list. So it takes in a list of students, and then we're able to tell it the number of rows and columns. So basically we're telling it the size of our classroom and the number of seats, and we're putting in a list of students, and then it's going to set up our seating chart for us. And it says, let's see, this creates a seating chart. So the constructor itself creates a seating chart from the student list. Rows and columns, we covered that already. Students appear in the seating chart in the same order as they appear in the student list starting. The seats are filled column by column. So most of the time when we've been filling arrays in our labs and that kind of stuff, we've been going row by row, right? So we're filling in row major order. It's actually different in here, and I'll show you. You just have to, it's just a simple difference in where you add and subtract. We're actually filling in column major order, or we're filling column by column. It's not that hard to implement, and I'll show you how to do it right now. So part A, we're going to write the seating chart class. We're going to write the constructor for the seating chart class. It initializes the seats instance variable, and it fills everything up by column. So for example, if you look, column major order, right? Karen, Liz, and Paul. Karen, Liz, Paul. Right? Lester, Henry, Renee, Lester, Henry, Renee. We're going down, right? Normally, again, what we've been doing is going across like this, row by row. We're just switching it up, going column by column. So here's how we do that. Start with our list of students. We initialize seats to be the size, rows, and columns. Let's see. So this is the way that I would do it. But you're free to. There's a couple different ways to do it. There's a second way here. but you're basically just looping through the list of students, right? And you're setting the value of your array at row column to whatever that student object is. And we're starting rows and columns both at 0. And then you're going to add 1 to the row, right? So if we look at how that works, so I'm adding Karen here, then I'm adding 1 to the row number. My columns are staying at 0. I run the loop again. My rows change, but my columns the same, and then I'm adding the next value here. Okay? Then if R is equal to, or if R reaches the total number of rows, so you could actually put greater than or equal to here, right? So essentially, if I'm adding the number, if I've reached the end of my row or the end of my column, right? Because the total number of rows is beyond, or is the index that I'm on is greater than or equal to my total number of rows, that means I'm here, right? So then I start over to 0 and I add 1 to the column. So now the next values, I'm starting at row 0, column 1 here. And then we just keep going column by column. Make sense to everybody? You could do a 2D for loop, which we've done before, but we've done the 2D for loops we've done before have been for int c. So we've done, or no, that's not how that works. So we've done these before where I'm going row by row, right? And we tuck it into a while loop. The difference here, I think I screwed this one up actually, is yeah. So that's adding it like in row major order. What I should have done is flip these. So RC equals I plus plus. Yeah. So what I would essentially do is do that. So as long as I still have values in the student list, I'm going to do that and run that loop over and over again. But like I said, I think this way is like just a ton easier to conceptualize because you're starting with the values of list, and this just is kind of a simpler way to describe what you're doing row by row, column by column. Big questions on that? All right, part B, we're going to remove the absent students from the array. So we're going to replace these students with null if their number of absences is greater than or equal to 4. How many people would still be in here if we had that rule here? Maybe 2 of you. So if you look, we start here, and you can see the number of absences, right? There's a 5 and a 4. 5 or great. There's a couple people. Somebody has 9, but you can see those all get changed to null. So that's the ultimate goal of what we're going to do. So what we have to do is pay really careful attention to this. And again, if I was working on this quiz, I would just copy that stuff in here. The reason why is this guy right here, right? We have a method that is part of, no, that's not what I was wanting to do. We have a method that we weren't privy to before that it did not explain to us, which is get absence count, right? So my student objects that are in this array have a method called get absence count where I can get the number of total absences that they've accrued. And I don't know if that's per semester or what, but it doesn't matter. So I'm going to make this remove absent students method, right? So we're going to remove all the students that don't want to come to class that often, which means all the seniors. They're trying to get rid of all the seniors. So let's try this, right? The other thing that it does that we have to remember is that it returns, where does it say that? They don't say it in the post. Here we go. I want to make sure we're returning the number of students that we remove from seats. So before we even do anything else, we know we're going to set up a variable to count the number of students that we removed, right? So going through each row, it's just a 2D for loop, right? It's not anything big deal. These are pretty, like, we're just looping through a 2D grid. So this increments our rows, this increments our columns. If the array seats at this position is not already null, so if we haven't already removed this student and the student object that we have at that position in the array returns more than this number when we run get absence count on it, then we're going to set that value. We're going to remove that student and set the value at that position to null. And then also we're going to add one to the count of the students that we quote unquote removed, AKA seniors. And then we're going to return the total number of removed students. Remember to put that completely outside of the loop. If we're still looping, are we done counting? No, we are not. So that's going to be a big one on your answer. Make sure that you return after the loop exits. Questions? I think once we take a look at these, most of them are pretty straightforward. This one's not. So the checker object, what we're going to do is we're going to use a bunch of objects that they're very similar, right? Everything implements this checker interface, and then all the objects are pretty similar. There's only like kind of slight differences in the way they work, and a lot of them even use each other, right? So this is one of those that it becomes pretty easy if you just write stuff down, okay? So if I just say interface checker, really all I have to do only have to run accept. And that one returns true or false. I do this really quick. So while you're thinking about this, it helps to write stuff down just so you know it's there. So now we're going to write a class Substring Checker that contains that'll accept any string that contains a particular substring. So if we look at this, our accept method takes in a string, right? It checks it against the string data that's already contained in the substring checker object. And if that string is in there, or if the string that we've taken in contains our substring data, then we accept it. So what does that exactly look like? Well, it's going to ask you to write it, so we have to take a look, right? So substring checker looks like this. So make sure you write implements checker. Obviously, it's saying to take substring data, right? So we know one of our instance variables is going to be a substring. We're going to set that up in the constructor. And now all we have to do, this is, I'm sure there's a more complicated way to do this. But again, you want to make sure that your code is light as possible, right? So this is really all we need. That's all it told us to put in there. We don't need to add anything else. And then we're going to implement except. Again, taking a string, return a Boolean. And it says it wants us to return true if the string that we're bringing in, right, that the text contains our substring data. So we just say if the index of, so if we run text and we look for the index of whatever our substring is, and that's greater than or equal to 0, then we know it's in there. What's going to happen if it's not in there? What value does index of return if the text is not in your string? Returns -1, right? So that makes it super simple. As long as we get a return from this that's greater than or equal to 0, we have a true statement. Otherwise, it's going to be false. So again, we could do if this, return true, else return false. If that's how you want to remember it or conceptualize it, you can definitely do that. It's easier to just return something that's already a Boolean condition. Any questions about how to set up substring checker? Okay, I'm going to leave substring checker up there because we're going to use it in the next couple of things that we're going to write. Now, we have a different kind of checker that we're going to write. So we can combine this is the thing that's tricky about this one, is that we have to combine different kinds of checker objects and know what they actually do, right? So an and checker, and it says for example, so that's kind of a tricky little piece of something, but let's just write it down because I don't know if we're going to use that later. Let's just say class. And I'm going to write some information about it, right? So it's saying it contains 2 checker objects, right? So those are probably instance variables. So to be like checker A equals new, whatever, right? So an and checker, and then the accept method returns true if both, let's say both are accepted. Or both contain so it doesn't matter what the checker is, right? If the accept method returns true on both of these objects, then the accept method on the and checker returns true. We have questions there? All right. So it's asking us to write the and checker class that implements the checker interface. So we're going to have to do this, right? So even though we just wrote it all down, we have to actually do this and make it and add it as part of our thing. So Part B, we're writing the and checker. And this one's actually not that complicated, right? We have our checker objects, checker 1 and checker 2. Okay? We set them up in the constructor. We take them in as parameters. Done. Now we write our accept button, right? So checker 1 is a checker object, so it has. So we pull in text as a parameter, right? We run the accept method on checker 1 and on checker 2 to see if they have the text, right? Or whatever's happening in the accept method for that object or that type of object. As long as that returns true for both, then we get a true here. And we get a false otherwise. Okay? So now that we've written that. So that's what you're writing out for part B. Okay? What I would do on part C is I would not think about that and only think about this. We don't need to know what the inner workings of it look like. We just need to know what it does, right? Same thing for substring checker. So I'd probably do this, class substring let's see. Substring. It has a substring as an instance variable. And then accept, returns, and then it also takes in another string. So it takes in a second string, and then accept returns true if the input string contains the substring. You with me so far? Okay. Let's see. So the implementation of the checker face. Another implementation of the checker interface is not checker. One parameter constructor takes one checker object, right? And an accept method that returns true only if its checker does not accept the string. So this is weird. So then it's asking us to construct a checker that accepts a string if and only if neither of the input strings contain artichokes or kale. So it's giving us this. Right? So substring. So we know we're using the substring checker. And it says neither, right? So we know we're using a not checker as well. Where did it talk about? So we know that we have a not checker, so we should write that down, right? Class not checker. One parameter, let's say checker object. So it takes a checker object as a parameter, and it takes in a substring or a string returns true, not tour, but true, if except returns false on string returns false on the object. So pull in, it's not checker takes in a checker object as a parameter, also takes in a string, and returns true if you run except, put in the input string, and it returns false. Everybody there so far? Okay, so we're starting with these checker objects. Let's see. Let's do this. So we start with these checker objects, right? And we put in artichokes and kale. So what we have to do is we have to use a combination of and checker and not checker. So not checker is going to return true, right? And not checker is going to return true if these don't, the accept methods on these return false. So we know not checker, right? Takes in a checker object, which we have this checker object that we put in there, and this checker object that we put in here, right? And if we run except with the input string on those objects and it returns false, then our not checker returns true, right? So it returns true for not, and we want to get a return true for not on both of those. So instead of writing that functionality out, we run an and checker with two not objects. Is that too big? Like most things in life, complicated, more of a complex problem. Most of the solutions are usually simple. Anybody have questions? Okay. Even some of these will be doozies, right? But what I'm trying to show you here is how much easier it gets if you just start writing down the information that you need as you go along. Like just kind of shorthand it, and it makes some of the other decisions easier. All right, so I think that's it for Form 3, unless anybody has any big questions.